Awesome.
while I remember, because I
Yeah.
will forget. Zoom is so much better than me. What's the other one that we used?
Go to.
Go to, yes, so much
Yeah.
better.
Agreed. Like, I was not a big fan of Go to.
Yeah. See, got Portugal swag in here. I actually need to go to Lisbon at some point.
Yeah.
Yeah, I've got a friend out there. Maybe if I do that, do some meeting out there.
That'd be kind of cool. I've been trying to do a trip out to Hawaii. There's a Hawaii Swag group that wants me to do a virtual presentation. And I'm like, why don't we talk to Dan and have them ship me there?
Get you a bike.
I don't even need the bike. I just need like a couple days. I'll pay for my wife to go, but I'm not. We'll go visit. It's like one of those big telescopes.
Yep.
So I think it'd be kind of cool. It'd be fun to do. Let's do this here.
Very interesting. I might have 2 meetings for this.
Whoops, that's okay.
I think I'm in the right one.
Well, we got 4 people in here, so us and 2 more. So
because in the middle of this, I linked Meetup to Zoom, and I don't know if that's created a new link.
I don't know. Because I used the link. Let me try it again, see what happens. Let me go back to that to make sure.
I think it's a different link.
Uh-oh. Yeah, because I just pulled the thing directly off my LinkedIn because I posted it on there.
Yeah, the link there is good.
It is?
Yeah. I think I'm just going to remove, I think I've just shared this meeting.
Oh, I see it. Yeah, the online event has a different number than the one in the details. If you look on the right-hand side of the screen,
Yeah.
it has a different number than the one that's on the details.
I mean, it seems to be working.
Oh, yeah. Or they jumped in from the other one. Use the meeting ID and that kind of thing.
Yeah. Okay.
Cool.
Yeah, it's doing something weird. That's good
all
to know.
good.
I think yeah, it looks like Meetup's just generated a second link and
It's
slide
weird.
that in there.
Isn't that
It
great?
should all be the same now.
Let's refresh the page. Yeah, it's good now. It's matched.
Sick. I think on that note, it's good point to start. How's everybody doing? Thank you for joining us. This is the London virtual meetup. Usually we'll try and meet up around London, but I like the virtual meetings a lot because it means that we can have people from all around the world, people presenting like Brad, all the way from Virginia in the US. We got the leader of the Portuguese Swagan, which is fantastic. And it's great to see some fresh faces as well. So, also with an online meeting, it's quite easy, quite quick. Brad's going to show and prove to us that we are the cause of our model issues. I'm really looking forward to that. I'm going to introduce him in a little bit. Brad will give us a little presentation, then we'll wrap up and show off the next meetings that we have on my agenda. There's a beautiful man, Brad. He's an engineer at Alltech. They make cool cranes and stuff. He runs the Star City Swag in Virginia. He does the Iron Swag. If you don't know what Iron Swag is, head to ironswag.com. The short of it is him and his buddy climb on motorbikes and travel across the United States, and in every city they stop in, they do a different SOLIDWORKS presentation. at different user groups. Madness. I've always found that Brad's a wizard at tips and tricks, and he's got an amazing beard that definitely grows a lot faster than me. For reference, then, both Brad and I shaved our beards at a charity event in February, and his just, it was like next day it was back, like nothing happened. I hope that's a good enough introduction, Brad.
Yeah, that's good.
I'll hand it over to you.
All right, let me share my screen here. Oh, it says you've disabled participant screen sharing.
Okay, try it now.
All right, there we go. Awesome. Let's do that. All right, so we will let me know if everybody can see everything okay. All right, can you see my PowerPoint? Everything
Yes.
good?
Yes,
Awesome.
sorry. I just stopped sharing my screen.
Oh, okay.
Okay, cool. I can see it. So if you can't see it, let us all know.
All right. I think we're good. Awesome. All right. So today we're going to dive into why you are the cause of your SOLIDWORKS problems. So let's see, get it back going there. There we go. Again, amazing intro. Dive a little bit into my history a little bit. I'm a 11-year project designer at Altec Industries. So I am just below an engineer. I take engineers' designs and make them machinable, buildable for our facility. 17 years almost. I'm right on the cusp of 17 years of a SOLIDWORKS user. Star City Swug leader, as Kirby mentioned. The Swugin Mid-Atlantic Community Representative, Committee Representative for SOLIDWORKS, a CSWE, and a SOLIDWORKS champion. And in the all that as well, I also am going back to school for electrical engineering because why not? Sleep is for the weak. I'm going to keep, I'll figure out some time to do it. So let's go back, way back to 1999. Our company, Altec, decides they're going to go from their standard computer vision and AutoCAD prints to SOLIDWORKS. So we started modeling trucks and getting chassis from our suppliers, modeling the parts, and putting them together. In 2014, after years and years of just doing it on, Microsoft networks, we decided we were going to go to a PLM. And then in 2015, we decided, let's go ahead and make a full, complete sales model truck of what our customers are going to see. We can show them a full 3D package. We can spin that thing around and kind of showcase everything that they're going to get, which really helped out our customers. They really liked the way this kind of manufacturing and engineering design and everything went together. And then we have engineering across the United States, and we have a couple locations now in other countries as well. So we have all this data being generated daily, thousands of parts daily. So we started running into problems. In that time, we noticed that we were having problems with files being downloaded, files being saved. It was taking us tons and tons and tons of time to open, modify, and save prints. And all of our engineers are getting frustrated. Parts were getting overwritten because, I can make it better. I don't like it that way. So we decided with this creation of these sales models, let's kind of partner with our two VARs. They're now Go Engineer, formerly AlignX and CATI, and Trimec, which is our other VAR. And we pulled everybody into a facility at our company along with 20 other user group, 20 other SOLIDWORKS super users, with people from SOLIDWORKS R&D and people with these VARs. And we sat down and created like a future state of what we would like. We kind of partnered with these VARs to help us out. Oh, hey, I see we got another participant in there. He looks like he's everywhere, even showing up in Chicago at sometimes. All right. So with all that, we had this modeling center of expertise. So you might see COE pop up a couple times. Centers of expertise. We have those little Altec logos in the cities where all these representatives are based. We have facilities at those locations, and we wanted representatives of each one to kind of give a insight as to what the problems were. So we've set a group expectation. We decided, hey, we are going to find the right people. They wanted to be engineering roles or designers, experienced SOLIDWORKS users. I don't think anybody in the group at the time had less than 10 years experience. And then the approval, obviously, for the manager. And then, you know, we were going to get the new standards and practices. We were given full control of like setting expectations for the group, for the modeling practices across the country. And yes, Eric, we do have a facility in California. It's in Dixon, which is just outside of Sacramento. Beautiful facility. It's one of our West Coast final assembly areas. So it's always super cool to go out there and visit and check it out. So we always like, you know, like if I get a chance, you know, oh darn, I have to go to California this week. Let's make that trip, you know. All right. So what we're going to do today, what, you know, of course, you know, meeting, we're going to go super deep into the SOLIDWORKS 3D graphics pipeline, how your machine actually generates your part, your assembly, and then how to optimize them into those for performance. All right, so what are the deliverables of this modeling COE? Well, as you can see, we have this, it's a lot of data on the screen, so we'll kind of go through a little bit of it here. We have a timer up in the top left of the screen that just tells you how long it took for that model to open from the machine itself. It's 3 minutes from when we click the open button to when it actually showcased and we can actually fully resolve it. And you know, we have this in use over here, and over here system memory, and we wanted to see before and after what was going on, because you know, this is what we're doing. I mean, computers are what we do, and if you're opening something, it's going to take forever. What's going on? We're gonna kind of figure out how it works and why it works. And after we got done, you see we got a considerable, we'll jump back, your usage back and forth. We were able to get saves and opens down a little bit and kind of go through that. So we'll go into computer graphics, how your computer showcases those files. Now, I'm not an expert at it. This is the stuff that was provided to me through SOLIDWORKS and Linux and Trimax. So I can give you an overall look of how this works. I'm not you know, an actual CS major, so I can't give you a reasoning why they decided to do it this way, but we'll continue on. All right, but before we get started, you say, Eric, those tools, what tools are you talking about, Eric? Are those just the performance monitors that were there?
Yeah, Brad, those, of course I recognize, you know, performance evaluation from SolidWorks, but the other panels, I was like, you know, was that something you cats developed in-house, or did you like find, hey, you know, I found this on downloads.com and this is a great, you know, tool for
I believe the guy who set the meeting up found it all online. None of that was derived through our IT department or our programming department. It was stuff that we needed to, at the time, get all the information for. But later in the presentation, I'll show you something that we developed that will kind of help you out with it as well. We've developed it and we're trying to, we use it here. It's all internal to our company. But before we get started, little caveat, no matter how big how current, how massive of your workstation is. You could have an FEA machine, you can have a laptop. You only have a finite limited number of what they call instructions per second that your machine can perform, and it's based on graphics card your CPU. So the GPU and your CPU control that. You might have a massive machine. Your company might give you the best of the best to do your job, but it is limited. And so this is things that anybody can implement to make their life easier when using the software. So we're talking millions of instructions per second, millions. So we've got an Intel i7. So this was at the time when we started doing this. i7 was the cream of the crop. Now we've got i9s that do way more. But 35 billion instructions per second is what that i7 is capable of doing. So that's every command for the whole machine. And then we've got filling and shading files, triangles per second for your graphics cards. So workstation graphics cards can display about 190 million. That's if you're not doing super big, gaming machines, and you have these, $5,000 graphics cards. These are just the, modern workstation graphics, especially in laptops and stuff when you've got, hundreds of computers you're buying. So 190 graphics triangles per second. Graphics triangles are how we break things up. We'll kind of show you how that works. So what we were trying to do was to fix SOLIDWORks drawings, large assemblies, and parts, and how SOLIDWORks understands and how it produces those images you see in your designs, everything on the screen. So kind of go into the graphics pipeline now. So we have tessellation, Z clipping, and HLR. Again, we're going super nerdy here. Just kind of show you how your computer thinks and then how to manage it. So we'll go to tessellation. So on the left-hand screen, you've got a cylinder. Your computer sees it actual round cylinder. You see it that way, your eyes see it that way, because they're really super good at picking out those things. Your graphics card cannot display a curved image ever. It's got to break it up into lines. So how do you break up a cylinder into a bunch of straight lines? Well, they design these graphics triangles. So they've got lines that do to and from, little short lines, and it's called tessellation. And it breaks them up into those triangles and then fills each of those triangles in with an actual plane and breaks those up. So if you do FEA analysis, you'll see when you do a mesh, you'll create triangles with your mesh. If you're doing surfacing, you might see like curvature cones and stuff, and that will help you out as far as finding the tessellation on the parts that way. So what ours perceive, real object, we tessellate the smooth surfaces and we shade it in. So a cylinder, right? 164 graphics triangles, just something super simple. And it's just a binary file. All that stuff is initially stored in your templates. So you've got your system properties and your document properties. So each thing is in the template for the document itself. You've got 2 slider bars in your document properties for image quality, HLR resolution, and your wireframe. So you've got shaded and draft, and then your wireframe. You want to be to the left of the middle. So farthest to the left, you'll have looks more choppy on your display, and we'll kind of show you an example. The farther you go to the right, the higher the image quality, the more triangles it's going to create to smooth out that line, that sketch, that surface. And if you get it obviously closer to the right, it says on there slower. You might use it for doing, quick renderings. If you don't have a rendering software, you can slide that thing all the way to the right to make it look nice and smooth and send screenshots or show your customer. But if you're doing everyday modeling, keep it to the left of the slider bar. Yeah. So all the way to the right, it's going to make it slow. It's going to make that computer think harder. All the way to the right, or all the way to the left is going to be super choppy. So you kind of want it to be just to the left of center. Real life example, you zoom in real close on something. You might see that round shape is now an octagon, or it's got multiple, numbers of sides. This is just you might look at your screen and go, oh, that's not right. Why is it looking like that? If you are familiar with the old AutoCAD days, you can zoom in, zoom in, zoom in, zoom in. It gets choppy, and then you hit rebuild, it gets smooth again. This one will do the same thing because it's having to tessellate that surface into a bunch of lines, single lines. Again, the more lines you see, the more calculations it's having to do. So we'll go back to your graphics card. Modern graphics cards, about 190 million filled triangles per second is calculating. So if we take that simple cylinder and put it in an assembly, you can do 1.1 million of those in that assembly, and your graphics card will still be able to showcase it effectively. That's kind of an idea of how many faces that thing can calculate. So 1.1 million simple cylinders in one assembly, which will be the max what that graphics card can do. Ooh, yeah, you're right, Eric. Good point. Another tell is that you'll fly your cursor over a choppy edge and you'll see the highlight of the smooth. Yes, that's a good one. That's good. So with that, why is it so choppy? I like that. Choppy edge, and links right into my next slide. It's like Eric's a time traveler here. I don't have a million parts, right? I might have 5,000 parts, or I might have just one really super curvy model. If you're doing 3D printing and you've got all these super swoopy faces and surfaces and things, but not a million parts. Why is it taking so long to display? Why am I, when I'm rotating it, it gets choppy? It's frustrating. I'm sure everybody's gotten to that point. I'm frustrated. I'm mad at my machine. I'm going to go walk away, get a cup of coffee, or just shut it down and restart it and see if it fixes it. Let's add some text to it and a chamfer to the edges, or a fillet on the edges. Yeah, it doesn't look too complicated, correct? But you see on the left-hand screen, a left-hand picture, your triangles have suddenly exponentially exploded. We now have 4,800 graphics triangles in that file just by adding 2 fillets and text on the surface. 2,800% increase in calculation just by adding 2 features to your part. So now that 1.1 million cylinders in an assembly has to be shrunk down to 39,000 components in order for your graphics card to calculate the faces, to calculate the facets and be able to actually think. Because you don't want to overload the system completely and just shut the machine off. Again, you have a finite number of calculations you can do. So we'll back it up here so you can see it. All you had to do all that to blow up your machine with that current assembly is just add text and fillets. It's just adding simple things that you think is simple, but the computer's having to do extra calculation. So the worst ones out of anything I've ever seen in real life examples, springs and screws and nuts, like anything with a threaded feature on it. Download a spring from a file. It looks nice and swoopy. It looks really good. But that has a lot of shape calculation it has to do. This is the worst one we find when you start downloading parts. I don't know if anybody's ever heard of McMaster Car, the website. We can download any file on that website. It's 3D model on it. Screws, bolts, casters, anything like that. You want to make sure when you open them up to do some part simplification, because you start downloading a bunch of springs and putting them in your model. It looks really nice. It showcases what it looks like to your customer, but it's wreaking havoc on your machine. So we got the tessellation down. It's broken that thing up into the faces. It's filled in those faces. Step 2. So it decides next what is visible from the viewer, right? From the screen. So you're rotating something around on your screen. You want to be able to show and see only what you want to see. We're going to draw a person, a truck, and a house, a square structure. You don't want to see every single face, every single edge. So the computer has to block out what you don't want to see. So what it does in this view, it's got 37 complete visible edges. It actually has to go through and clip out all the other ones that are not seen, including that entire person that was in the back. And then after that, it goes into HLR. Now remember that setting that you saw, HLR shaded and HLR wireframe, that actually is where you start getting a lot of your complication. That's your partially occluded things. So if you've got a face that's partially shown, that's where it's at. Z-clipping and tessellation is only for full features, like full lines, full faces. This right here is where your intensive computations come from. It's having to break apart a single face into a bunch of other smaller ones to showcase only what you can see visible parallel to the screen. So you rotate that part around, it's having to recalculate what is being shown at the face of the screen. So this is where your graphics card starts screaming. This is where the math is going on in the background. You just don't get to see it because SOLIDWORKS is great and doesn't want to show us on the side, like a DOS command of all the calculations going on. It'd look like the screensaver from the Matrix. It would just be nuts all the time. So a good example, oh man, it didn't show up. There you go. A good example is that edge of the house, right? It's actually one continuous edge, but HLR calculation had to go through and only show the top and the bottom portion. And it completely hides the person. So your computer is doing all this every millisecond to showcase whatever you're designing. So it goes from a bunch of wireframe lines to an actual photo that you can see. But how does it help me as a designer? Yeah, I just got really super nerdy on the thing. So what we did after sitting there, drink a cup of coffee, and like take a smoke break from after CS majors tell us how this all works, what do we do as a company? Okay, we have all this data that's going on. I don't know what to do with it. So we decided we're going to run a test case, a couple of them actually. We ran, each person in that room ran test cases during the week. And so we found a couple really heavy hitters on files. What files are really giving us the problem? One of them was a hydraulic reservoir. So this is a purchase part. We don't make it. It looks pretty simple, right? A square box with some stuff on the top. Well, we downloaded it from our supplier. It's a multi-body part rather than an assembly. So it's having to go through and calculate each body as you open the part versus calculate each part in this assembly and then just display it as the assembly. That's a strike one. It's a multi-body part, which makes everything calculate inside the part file itself. 18 million graphics triangles from a downloaded part. I had to censor out some file save data on there, but the graphics triangles themselves was what was really crushing us. And yes, will that the freeze bar will work for having to recreate certain things in your that's for rebuilds and whatnot. The problem is for our machines, at least for our test instances that or at least our instances that we use, not everybody knows how the freeze bar works, and our stuff is such fluid in design. We do custom trucks. Freeze bar really doesn't benefit us any. But yes, that was a good statement and good question. So just on this one part, we have 1/10 of our graphics card calculations just on this one thing. Now it's got to calculate the rest of the truck with what's left of the graphics card. We did some digging on the part. We opened it up. It's got a baffle in it with a bunch of holes. It's having to calculate every one of those holes on a part that's not even shown deep in an assembly. I could care less how this baffle is shaped. I'm not the fluid engineer who's designing the actual tank. I might work with them and have them say, okay, this will work, but in the model itself, nobody cares. But yeah, I will. I'll definitely have to get with you. If you can, reach out to me, and I will do it. brad.metter@altec.com. We'll do it. But 12 million of the triangles that you saw in that part was just on this grading that nobody sees. Come on, there it goes. So, not shown calculations. How in the world do we expect our computers to work when we're asking it to do things that it's not needed? We tell it what to do. It just is yes or no operations on zeros and ones. So part of our thought process is let's go back to an assembly. So we went back and we decided let's bust it up into individual components. That way it's calculating one part at a time. And it's giving us a little bit more flexibility in how we can hide and show the parts, how we can hide and show things that are needed for it. And we got it down to 136,000 graphics triangles just by getting rid of some internal parts that we don't see anymore. Specifically, that big grate in the middle of it. We don't need it. That big baffle grate. This is kind of how it looks now. All the service parts have individual part numbers to it. All of them are just simple representations of things. They are still in there. You can't see them from the actual model itself, from the big truck, but we have to have them in there for serviceability. These are service parts that we have to buy. And we got that baffle down from 12 million graphics triangles to 12. I don't even know what percentage that is, 99.99999%. Calculation savings. And we'll kind of show you here's a little sneak peek of that model health checker that we created to show it.
A file somewhere that all sets in it that we could just put into.
I heard something, a question. Can you repeat that?
So I think I like that sounded like a background noise, so I just muted everybody. I think it was Will asking a question. Sorry.
Oh, okay. Okay. So there's a little sneak peek of what one of the things we developed to help our designers. It's called that model health checker. So we'll kind of just go back to our modeling COE, right? We set the group expectations. What are the current problems? What is our ideal state? And then how we can prove it. So, we spent, a week, like 20 Altec employees and a bunch of SolidWorks people and a bunch of VARs in a room. So we went through, did a bunch of test cases. We did a top to bottom ideal state. We took a couple trucks Everybody took some parts. We went through and fully defined our sketches. We fixed all the mates and we simplified parts. And we decided, how are we going to target this stuff? We opened an assembly visualization, big tool. Use assembly visualization in your assembly files to showcase what files are the problem. You see all the red components in this are the files that have some serious problems. The chassis itself was 420,000. The actual cab that you see here, 420,000 graphics triangles. That is after we did the simplification of that baffle and the hydraulic tank. That one moved down to fourth on the list. But you can see we've got some work to do. We've got some problems here. So we went through and found face count, rebuild time, graphics triangles, and open. So you've got your face count, your open, and then you've got save times over here. We just don't have that shown in this photo. And then the graphics triangles themselves. And I like to sort them, graphics triangles from top to bottom. But you can see here, all these here, you can get a picture in your assembly visualization on what's the problem with your part, what's causing your computer to think. And yes, Eric Gobb's percentage, practically 100% increase in or 100% decrease in graphics triangles just in that one part. It's amazing what we can do with it. Another one is like downloading purchase parts, you know, the image quality cranked up to 100 on something from a purchase part. Don't do that. One of the ones that we saw big on the actual truck body itself on the door latches was the door latches themselves. We have and on the left a door latch with text and stuff cut into it everywhere. Again, don't use text extrudes or cuts if you don't have to. 200,000 graphics triangles, 1,400 faces, and a file size of 5.5 megs. Now, if you're using a PLM or a cloud-based server, file size doesn't matter. But if you're working on your local machine, your file size will end up taking a hit if you do like these complicated parts. Well, we went through and we simplified that. You know, the latch still looks very similar. The customer's never going to be able to tell the difference in the 3D model itself. And we went down to 130,000 graphics triangles, 600 faces, and the file size went down 1 megabyte, which in the grand scheme of things, if you have a server, it's not a big deal. But if you're working on a local machine, again, performance-based impacts.
Brad.
Yes.
What I'm finding absolutely fascinating about this is that while you're talking about graphics triangles, almost all these same rules apply if you're getting these manufactured, especially 3D printing.
Mm-hmm.
The amount of customers we get that will send files that are 150 megabytes with the most simplest geometry, and then we fix it and it's 200 kilobytes.
Yeah, it's amazing, isn't it?
So all what you're talking about, reducing these triangles just in your graphics, it also matters for exporting for additive manufacturing, which is
quite
interesting.
Yeah, and so we started looking at our suppliers. Like we did the same thing. We get a main valve or a hydraulic cylinder from one of our suppliers. The valve's got all the internal components in it. I don't care how the spool shifts inside that hydraulic valve. I don't need to know every ring or every seal and every piece in a cylinder. So we started simplifying the parts down and saw vast improvements in those. And so with that, we'll kind of go into some strategies for simplifying parts. This will help with your 3D printing. This will help with exporting parts. If you have massive files that you're exporting out to your manufacturers, this helps immensely. Especially if you're doing big, large assemblies, you know, full trucks, full, you know, assemblies, things with thousands of parts in it. That's where you're going to see it. So there's many techniques for part simplification. So we're going to dive deep into a couple of them. but the biggest one we'll touch is round trip geometry, but I want to touch on the first three. Feature suppression and bodies. So internal bodies to parts, suppress them. If they're there and they're never going to be looked at, like, like I was telling you, the seals and spools and things inside of cylinders or inside of electric motors, you don't need to see anything in there. You can delete those out. Feature body features and faces, deletions. And then we call ship in a bottle modeling. You can add features. So if you've got a electric motor, that's a body, solid body creation, and there's a bunch of stuff internal to it that's already been deleted. There's still a lot of internal faces. You just do an extrusion of a cylinder, fill up all those faces with a solid body, and make it into a big blob, essentially, that's just an overall thing. SOLIDWORKS does with the new, I believe it was 2018, the D-feature tool will do a lot of this for you automatically. Amazingly, a lot of people don't go through this. But yeah, manually defeaturing has gone down significantly with the creation of that. Feature, especially with I think it was 22 or 21, where they added the ability to have it as a configuration instead of an individual linked part. So it gives you like a simplified configuration itself, or a defeatured configuration. And then we're going to talk about round trip geometry. This actually might be something that you're doing, Kirby, at your facility. Do we have a question? No? Okay, cool. So we'll go to the fourth one. It's a little bit more complicated, but I got a video to got a couple videos that'll show you how to do round trip geometry manipulation. So first thing you got to ask yourself is, what do you need for your purchase part at your top level assembly? Accurate space. Do you need custom properties, weights, CGs, and then a reasonable, not accurate, a reasonable 3D representation for something that's 2 or 3 assemblies deep. So we're going to go through an overly complex OEM part. We're going to basically save out exactly what we need, and then we're going to drop it back in as a simplified configuration. And we're going to do it with a latch. So you probably see these on toolboxes all the time. This is actually not one we use. This is a complete separate one, so we'll kind of even up them apart. But you can see too much detail in this thing. We're going to go, and it's time to simplify. Let's see if I can get it to play. There we go. So we're going to take this part. It's got everything in it, all the nuts, bolts. It looks like we're even missing a pin in here. But what we're going to do is we want to select everything we want to see using the select tangency command. So pick everything that we need to see, that our customers are going to need to see for space claiming inside of a part. With the selection tools that SOLIDWORKS has, we can just collect anything we want using select tangency, or we can even use the different lasso select or anything you want to use. We're going to go up to our save. We're going to save it as a step file. The newest one's the 214. We're going to go to the step file, and we're going to save. And we're going to say just selected faces. That's all we want, just the faces that we want to see. Now we're going to go back through, and we're going to open it, and we're going to import that new stepped face, and we're going to create a simplified configuration. So first thing we do, create your configuration. For us, we like to use, simplified because of our way our PLM is set up, but you can name it anything you want. And we're going to insert the part inside the part itself. You know you can do this, Kirby?
I've done it recently with working with 3D scans and that kind of stuff, but
yeah, insert the part inside the part, basically creating a circular reference as to what you want to see. But what we're going to do is we're going to suppress all the other bodies in that simplified configuration, and it's going to get you only what you need to see. And gives you both of those options. Simplify it at one time. And you can dump that back in your PLM software as is. So we did that with a Freightliner cab. I can't really show it to you because it took hours to do. We were doing it as a test case, and we're like, this thing actually worked really well. Let's just dump it in. Well, we got a email the next day. It's prior to Teams. Got an email the next day from a lady. The top little chat bubble was actual text from the email. Not sure what you did to this. It opened fast, almost no wait time. This really helps. The lady that was leading the meeting stopped everybody what we were doing, showed it up on the screen. We couldn't, like, we just with the cab of the truck, that, you know, it's just a visual representation. We don't do anything with the cab itself. And then a couple days later, it looks different, but when it had opened, it was there. It looks great. And then somebody said, haha, sweet, clean up the cab model. We had no idea that people were actually seeing this. We just kind of dumped it in. Whatever. It was almost, it's like 8 hours later, we're getting feedback from our users all over the country. These were all different people from different locations. So doing a little simplification here and there, if you take the time before you start working with the models or before you start working with assemblies to simplify your parts, really does help out. Now, Kirby, I will ask you, do you have to simplify or redo your imported geometry for 3D printing? Do you have to do it a lot, or is it like an everyday thing for you?
So if it's really complex, most of the time I will rather get our customers to do it themselves because they know the CAD the best.
Okay.
Tell them, clean up the stuff. A lot of the time it comes with companies like yourself or architectural companies who want to print models. It will take their full-size model and just shrink it down.
Mm-hmm.
And it'll include, just like that tank that you had, all that details inside of the tank, and it's just too small to print.
Mm-hmm.
Like we've had someone who was trying to print like an arena that had every single seat in there that was way too small to print.
Oh my gosh.
Tens of thousands of bodies. And we can't print that.
It's like, can you hide them at that point?
Just get rid of it. Stuff that's too small. You don't need that, because most architects just want to see the outside of the building. We don't need to know what's going on inside.
That's amazing. I never thought about doing like that level of detail. They'd send you that. That's nuts. That's impressive, actually.
So we usually do a process called shrink wrap, which basically puts a wrap around all the outer bodies and everything inside just gets deleted.
Okay.
So there's no internal details in that.
Okay. Now, have you used the defeature tool much in SolidWorks?
Not so, because most of the stuff that we get is STLs, sometimes step files.
Oh, okay.
So we can't really edit it. Usually it's that kind of stuff. And like a lot of what you're showing here can be turned into a 3D printing tutorial as well.
Yeah.
On how to simplify stuff, which is really good.
Yeah. I mean, things that we impress upon our users now is like putting all your fillets at the bottom of the feature tree. So if you need a simplified part, you just suppress the fillets. That alone cuts 50% out of the model size. Could have called it a simplified configuration and call it a day.
Yeah, I find fillets are the scariest feature because that's the one that usually crashes SolidWorks.
Yeah, because it's creating every little bit of an edge. You saw on that the example with the text and the fillets on the edge of the cylinder. Yeah. How many different graphics triangles it creates just with the fillet.
Yeah, that cylinder illustrated it very well.
Yeah. The bane of my existence, placards, kryptonite. We have users that love to create and extrude text onto a 5,000 thick extruded placard, and then take this placard and have it multiple times on a truck. How many vehicles you see with warning stickers all over it. Look at the bottom left, 22,500 graphics triangles in that. We dump it into just sketch only, and it goes into 172 graphics triangles. It is just showing the outside fillets and the faces that you need. You can take that a step further by creating a decal in SolidWorks dumping it right on top of your extrude, and call it a day.
I mean, that's, you just use a graphics body, like, or a sticker.
Yeah, that's yeah, a graphics body with a decal on top helped out like immensely. We're working on internally a process where you hit a button and it'll do that for you, because we create hundreds of placards every day. We have our own placard printer here, or sticker printer here, because customers want their logo on the side of the truck, or they want their logo inside when you open the door. Look at my, this is my truck. They want things flashy and pretty. So we can give it to them. Extruded text should be considered a hanging offense. I like that.
I mean, like the way video games create their assets, like on that truck, for example, it would be the most simplest low poly truck, but all of the details is created with bitmaps and graphics over it. Like all the shadows and all that stuff. So it looks 3D and all those details look like it's in there.
Yeah. And this is how every gaming computer, every graphics card works. So if you're gaming,
quite honestly, I've never looked at, like, I understand a lot about gaming graphics, how that works, but I've never put two and two together and like it's exactly the same thing.
Yes, it is. We're just asking our computer to show more intricate things at a higher level.
And it screams at us for it.
Yes, it does. This laptop that I'm sitting here beside gets hot and it doesn't like big models. And then you start throwing extra things in, like diamond plate extrudes. Holy cow.
So would a gaming graphics card try and read this different to a enterprise graphics card?
I think graphics cards themselves read the same. I think it's just how the software interprets the calculations.
Right.
I think it's all software manipulation. I think the graphics cards themselves, they have a different clientele. They have a different install use case. I'm guessing a gaming card's a little bit bigger because it's in a bigger case. My oldest child is looking at getting a gaming PC. I can get a massive case with a water cool. I can't do that with all 600 computers that my engineers and designers use, because just the cost management at that point. So they're. I imagine the calculations inside of them are the same. It's just they have to fit them in a different package. But yeah, I've seen.
I know SolidWorks won't approve like a NVIDIA card that's like the 40 series and that, but they'll approve the NVIDIA enterprise cards and the Ryzen enterprise cards. So that's an interesting. Maybe we can try and find someone to answer that question.
That would be really a good deep dive into somebody for a class like at World. Why your gaming PC won't work for CAD or something, or will it work? I don't know. It'd be kind of hard to. I don't know if you would have a big crowd or a little crowd at that one, because that's a really deep dive into math there.
Because the most accessible graphics cards are your gaming ones.
Yes. Oh yeah. Unless they sell out. So I don't know. So we'll continue on. We're almost done. We got super nerdy here, but we're almost done. So we applied all the stuff, hiding bodies, deleting features, or suppressing features, and creating simplified parts, fixing the mates. You would not believe how leaving something floating creates additional calculation. Floating mates and floating sketches keeps SolidWorks thinking, okay, I might have to leave some resource available because this might move. A fully defined sketch and a fully defined part actually calculates faster than something floating. So if you've got a bolt that's made it into a hole, if it can rotate in the hole, SolidWorks software is still thinking, okay, this thing might move. I need to have some resource available. I need to keep looking at that specific part. And this is where your freeze bar comes in. If everything's mated and frozen in place, it doesn't have to recalculate that anymore. it says, okay, this is where I need it to be. I can release some of this resource to do something else. So we measured before and after in this truck. Rebuild time in seconds, 22% savings, 53% file size savings in megabytes. If you look at that as a full scale truck model, locally open times, 33% savings. And then the RAM usage was a 25% savings roughly for this truck that we were using as a demo. So, you know, it's not insignificant amounts of work, but you see some big performance wins, especially if you're trying to keep your finite usages of your calculator, basically your TI calculator, that is your CPU and GPU. You know, it's not having to do as much. But yeah, I could see where this, I never thought of it in a 3D printing way because my world is very limited on the 3D printing. We do small parts here and there, but I never thought about how this could be applied to that. This would be a
Seems
new
like you need to do it
understanding.
too.
Yes, it sounds like we do. We might have to partner with this on this because
Collab.
yes, 3D printing for moderate dummies. Yeah. So how did we do it? We got this thing. We showed it. We proved it. Well, we had a two-prong attack. Behind the scenes, we didn't do anything external to the rest of our supplier, or rest of our designers. We went through all of our hardware components, bolts, nuts, hydraulic fittings, washers, everything. We simplified them down, took every fillet, every thread, anything that wasn't needed for it out. We had a group of supplier engineers that went through and simplified chassis, the valves, the cylinders. And then we went through and found a group of people that we had and went through and simplified Altec models. The biggest thing we did was we went through our templates and set all the things that we needed that were really high calculators, like that slide that I showed earlier, the resolution. We set all that stuff down to a reasonable level. So kind of show back here. This is kind of how we set the templates up for success. It does look kind of sketchy. We zoom in really close, but most of our models are big. We're talking feet and inches or meters. We're not talking millimeters here. We're talking inches. Big feet, 3 foot, 10 foot. This truck right here is 30 feet or 20 feet end to end sometimes. So set the resolution really low. And we set that up default across all of our computers. And with all that, the modeling standards of sketch part assembly modeling, the mating, configuration, display states, flexible using envelopes, simplifying placards, and then going back and showing and using simplified hardware, simplified chassis models, anything that's supplier wise can be simplified. And then setting the templates up created and improved performance across the company. So that's the end of my nerd extravaganza. But I'm open for questions if anybody has any. We can do some live modeling. I do have one of those open. We can kind of show if we wanted to do it. Need a cricket sound effect on your stream deck.
I mean, I'm
brilliant
fascinated
stuff,
by
Brad.
I'll let you go, Eric.
Absolutely brilliant stuff, man.
Yeah, like I said, I can't take credit for the whole thing. We had this was 30, 40 people in the making with all this data that we went through, but it was, a significant important improvement. And now we're going to laptops for modeling for most of our engineers because we can do that because of the performance impact.
It's interesting. Like you've basically changed the whole ecosystem for the IT, the IT of your entire company.
Mm-hmm. Yeah. So
through
now
this, it's not just you know, a model opens faster, there's a lot of layers
Mhm.
to this. It's just, that's fascinating.
Yeah.
Like,
So like
you
when
said
the
it's nerdy,
pandemic,
but it was absolutely brilliant.
yeah, when the pandemic hit, you know, most everybody that was working here had desktops. Like, oh, you got to go home. Okay, so now I'm having to drag a desktop and 3 monitors, you know, all this stuff around with me to go work at home. Um, we saw the benefit of like, okay, well, do we really need this massive machine anymore? Can we order something that's down spec'd a little bit, maybe put it in a laptop size? Um, and so now everybody's got a laptop and a dock at their desk. You're not feeling good, we go work from home. The only thing you have to take with you is your laptop and a mouse. Or if you leave one at home, just carry the laptop back and forth.
Yeah.
Um, it really did change the landscape. I mean, we have people, oh, my kid's sick. I can't take off from work. I can now work from home.
Yes.
It's back and forth now. I mean, we have full departments that are work from home now because of it. It makes it so much easier.
I mean, it saves companies tons of money as well in terms of rental and all that.
Yes. Yeah. Well, we don't rent any of the equipment, we buy it all. But yeah, it does save a lot of money. We save for our at least our IT machines or for our engineering machines. We take all that money that we could use on just regular laptops and we put it towards the FEA machines. When we do really big calculations, we have big, massive things sitting in, you know, that it's not like jet engines running, big fans running, water cooled, you know, we put that money into those, which allows us to do our job more efficiently. So
It's incredible.
yeah,
That was awesome.
and at the time, you're like, why are we having this problem? Nobody else can be having this problem. And Trimac and Go Engineer, those people were like, no, you're not the only one. We can't tell you who is, but they're possible competitors. They're, you know, they said if it's not a competitor, like John Deere had the same thing. You know, they went through the same thing we did because they're not a competitor. They could tell us the kind of the same situations. You know, how to simplify these massive assemblies. You know, you can't have a full John Deere tractor fully defined, every bolt and nut in it. It would crash your machine. So
No. Yeah, like I said, we get some stupid models. We get people who have fully populated PCBs that they want to print out,
oh,
and it's just like, why?
that just sounds terrible. Like, oh yeah, I want every little surface mount PCB component
The
shown.
purpose is to prototype if it will fit. I was like, so just take the most important components,
Yeah,
model those on a little board. You're
the
good.
big capacitors. I imagine what they're doing is they're taking an Altium download of a SolidWorks file
Yeah.
and sending you the file. Oof, that sounds bad. Sounds bad.
We've got a circuit board that someone put in one of our models that every RJ45 connector for the Ethernet cables,
Oh,
the full little ultra thin sheet metal housing for that cable jack is in there. And again,
did they leave the pins in?
Oh, of course. And
Oh,
so to reference an old movie, if I were Patton, I would have slapped them, you know.
nice.
And
Nice.
just to show how, just to further illustrate, you know, what a performance hit it is, you know, you get the dialog box that when it's opening an assembly and you see the feature or the component count scrolling up as it loads each one. When it hits that circuit board, it actually sits on it for about a minute and a half.
Yeah.
And it's like,
Yeah. We had
I
some,
have deep divots in my tongue from biting it just to
yeah.
keep my comments for myself.
So in our core controls group, we have people that use Altium to develop PCB boards, and it's like, okay, we don't need everything on there, so they create a simplified version with none of the components on it. We just need to know the shape. You know, will it bolt into the module? And if it does, great. You know, cool. So, yeah, and this, over time, we've populated, this best modeling practices and stuff. Actually, I'll kind of show you our model health checker here. So we've got this nice toolbar that we've created. It's got a model health checker here, and it tells you all the stuff you can see. That it's all SolidWorks data, but it just compiles it into one spot. So you can say image quality. We have it set at 10%. We have a button that'll let you automatically fix the issue. We have a document you can click here, and it'll open and explain why. It'll tell you how many graphics triangles you have, if it's a scene amount or if it's an open part. So we'll jump into this part here.
And this is the internally developed tool that you were referring to earlier?
Yes, this is our internally developed tool. And it even does things like, this part was generated in SolidWorks 2011. And in 2017, they went through and redid all the calculation engine in the background. So now we need to go back and update this part. If there's any rebuild errors, it'll tell you. Like this one says that there's no material selected. Image quality is at 10%. It tells you how many graphics triangles you've got, any underdefined sketches. Is it an inactive part in our system, or is it rolled back? It's all internal right here, right in one shot. And so, yeah, it's amazing. Like the guy who created this thing, unfortunately, doesn't work for us anymore, but it's been refined over and over again now to where, oh, I'm going to save it in. Here's the problems. We don't want anything with a red X on it. So when you first save your part, revise it and save it, it goes to the newest version that fixes it. This tells you how long this part's been in use. But yeah, it's great. It's a great software to use. So let's pick another one real quick and check it. So again, this is all obsoleted stuff, older stuff. So this was 2014. It tells you what file. So I think it goes back anything that's 2 versions back or more, it throws that red X to you. So it helps out as far as the calculations go.
Great.
And this is all developed using SolidWorks API. So highly recommended if you get a chance. But I'm going to stop my screen and I will let Kirby reshare his and go to the outro kind of stuff.
Cool. So yeah, Brad showed us a good time. We nerded out, but I think everybody had a good time and learned something from that. And I think from that we can build a nice secondary kind of presentation. I've got 2 kind of meetups coming up. We've got the Slug Me, which is the SolidWorks largest user group meeting ever, or longest, whichever way you want to look at it. That's streamed on YouTube on the 26th of October. I will actually be attending that. Basically, we're building something awesome. We're going to have a team of designers designing it, while a group of makers like myself are going to be in the maker space at SolidWorks building it at the same time. It's going to be awesome.
And I've seen what they're going to be building, and it is awesome.
It's awesome, but I'm scared because I've got to build it.
Yeah. So,
and then on the
You're
15th of
scared,
November,
I'm confident.
on the 15th of November, we're doing our regional event, which is an in-person event, which will be held in Cambridge at the SolidWorks offices in Cambridge. So that's already up on my meetup page if you haven't registered for that one already. That's going to be fun. Eric Beattie, who's here already, will be flying through to the UK, and he'll be presenting as well as Johnny Harrison will be presenting. And it should be a good evening. A nice in-person networking event. So those are the next 2 events that we got planned, and then that should lead us up nicely to 3D Experience World in 2024, which will be held in Dallas. Yeah, Dallas this year.
Dallas, Texas.
Yeah.
We especially have to give Kirby a warning to be very careful, because Kirby and Dallas do not mix, as we've learned in the past.
The last time I ended up with a tattoo, so it can't be that bad.
I didn't crash a scooter though. That was Johnny.
We had a few people that crashed one too, because those things were everywhere, and it was like, $1.50. Let's do that.
So if you haven't heard about 3D Experience World, it's basically what we have here, this awesome presentation, every day for 4 days almost, in a convention center in Dallas, where SolidWorks users from around the world get together, node out, and learn from each other, and watch hundreds of presentations like this, and also get to see what's new and network with people that are working in the industry as well.
But just to be clear, most of those presentations are nowhere near as awesome as the one that Brad just gave.
How many of you submitted this year? Or for next year?
3.
3.
Yeah.
You'll probably
I've got 2.
I kept it down this time. Last year I submitted 5, and they're like, we can only let you present 2. It's like, okay, that's fine. I'll just have some of these in the background for later.
There you go.
No, this is great. Which means that Brad does have a lot of awesome presentations. Are you still doing some virtual presentations, Brad?
All of mine are now in person. As far as all of mine. My next one is actually October 2nd. Let me pull mine up here. Yes, it's next Monday. I'll send you a link and put it in the chat if anybody, I guess nobody here is local, but the college I'm at doesn't allow me as a visitor to live stream. They give me a limited bandwidth internet connection because I am a guest, even though I went there as a student, and I teach there about every month, so they still won't let me give me the full access. So I'm working on doing a combo.
That's excellent. Yeah, like I said, this meetup allows us to, especially when it's virtual, people from around the world to attend. But yeah, I think that's a perfect place to leave this one. It's been absolutely epic. Thank you very much, Brad, for presenting. Thank you, Eric, for joining in. Thank you very much for everybody that has joined in this evening. If you guys still have any questions, fire away. Ask any questions that you may wish. If not, I did put Brad's Swaggen email down in the back.
Yeah, I'll put it again. I'll put it in there again.
Yeah. If you have any further questions.
At gmail.com. It's real easy.
There it is in his meetup as well. But hopefully we'll get to see a few of you in person in November. Hope to see you in the chat on the Slug Me event that starts at 6 p.m. And I think it goes on for about 4 or 5 hours.
Yep.
Nice.
Kind of just showing fun design techniques to create something awesome that's going to be built at the same time.
Yeah.
Cool.
Yeah. So, but you guys have a great evening. Thank you.
And you've still got the rest of the day to go. Have fun, Brad. Thank you very much, Eric. Thank you very much, elsewhere, who's joined in tonight.
See y'all later.
Have a good one.
Take care, y'all.